Greetings. I appreciate this opportunity to bring you greetings from Purdue University in Indiana, USA. It's great to be part of the No Dig India show this year. And my name is Tom Isley. I'm a professor of engineering practice here at Purdue. I'm also the Beavers Heavy Construction Distinguished Fellow, which is Beavers is an organization that's made up of the largest heavy civil construction companies, and so it's an honor to have been selected to represent them at Purdue University. I also represent the board of directors of the Barrett Asset Management Institute, and also a pleasure to be part of the Xi'an Jiutong University in Xi'an, China. I will be talking to you today about the major milestones or developments in the trenchless industry. In other words, the major events over time that have really got us to where we are. When we look at the trenchless industry today, it's an industry with a lot of depth and a lot of breadth, because when we look at methods to install new systems, construction methods, or to renew the existing systems, there's just a large family of technologies that allow us to do that. And we are able to do it safely and also cost effectively. A lot of that has to do because of the ingeniousness of the individuals that make up our industry. And so I will mention several of them through my presentation. I'm not going to be able to talk about all these methods here, but I would like to say that in each one of these categories, we just see a continuous effort of innovation, development, expanding the envelope of the things that we can do with these different technical solutions. So it's been an honor to have been a part of this industry for the past 35 years or so. It was an honor for me to be part of 5 individuals that had the vision to establish the North American Society of Trenchless Technology in 1991, and to be a part of getting it kicked off and established in North America. So the technologies that I will be talking about that I refer to as breakthrough technologies that really allowed us to move to the next dimension of trenchless technology are these here: directional drilling, and then the mid-sized directional drilling, and the location equipment, pipe bursting. And you know, it's not just the technical solutions, but it also involves the ability to get the word out, get the message out, to increase the awareness, and that involves the media organizations that make up our industry, and then the organizations that have come together and expanded and covered trenchless technology. And we'll see about the in situ form technology, the CIPP, how they brought the technology into existence. And also I want to mention and reference the subsurface utility engineering and pipeline condition assessment and micro tunneling. So those are the major categories that I want to mention. In doing that, I'll start out here with the horizontal directional drilling, and you know, the real pioneer there back in the 60s and 70s was an individual by the name of Martin Sherrington, who was the first one to develop the capability of being able to surface launch, penetrate the ground, go down, navigate under some obstacle or feature, and then come back up. In this case, it happened to be a river in California. And so Martin was a road boring contractor, and he used slurry drilling to do that. At that time, we didn't have the ability to track and steer the steering head, but he was able to make that happen. And then what that did was give birth to a whole new industry. He's from California, but after he did that first launch, then the oil and gas industry heard about it and invited him to come to Louisiana and help develop that capability. And it's amazing to see how that's developed to the point where we've got drives now that exceed 2.5 miles. And so that's certainly a major breakthrough. And we've got to hand it to the innovator that really launched that technology back in the late 1971. You know, but then we had a similar type technology, mini horizontal directional drilling, that evolved from a totally different birthplace, and that had to do with research work. It came out of the EPRI, Electrical Power Research Institute, and they teamed with some industry people and was able to develop a smaller size, what often referred to as MIDI and sometimes mini horizontal directional drilling. And there we have to give credit to the company Flow-Mo that doesn't exist anymore, but they were the first ones that really commercialized the technology out of that research program from EPRI. And then following them came the Ditchwich technology and Vermeer, and there were several other firms that were involved in developing that technology back in that time frame. And so we see that segment of the industry grew rapidly. We started seeing in the neighborhood of over 2,000 rigs sold per year, and the number of contractors grew from 0 to over 6,000 in the early 90s. So it was exciting to see that kind of development take place. Now, it's about everywhere you go, you see these rigs doing their thing, and it's kind of common practice now. But back then, it was new technology, innovations that took place. Along with that came the guidance systems, being able to track where the end of that drill stem was located and being able to steer it. And so one of the companies that really was a pioneer came out of the Flow-Mo technology and became an independent company called Digital Controls, and that group, and they're still doing great work. But I remember early in the early 1900s working with John Mercer as he was developing that capability. So that technology has really allowed us to advance in the industry. Pipe bursting came out of the UK, and British Gas was the inventor and primarily developed for cast iron pipe, gas pipe, but eventually rapidly merged over into doing water lines, and eventually came to the United States. And some of the major players there was Jim Hopwood, who came from British Gas, but once it came into the United States, we had people like Chris Brayler and Collins Orton and Dave Holcomb that really advanced the industry. And advancing the industry took more than just having a great technology. It took being able to educate and increase the awareness and being involved in the industry and bringing confidence to the technology and standing behind the technology. In addition to the technical solutions that we've just talked about, we saw that it was very important for the industry to get their word out, to increase the awareness. And so we saw the Trenches Technology magazine come into play in 1992, and today over 38,000 subscribers get that magazine monthly. And also there's a family of magazines that's part of that publishing company. But we don't want to minimize the importance of publications, because again, that's how owners, that's how engineers and others, contractors learn about the ability of our technology. And then other magazines, the Underground Construction magazine has been a strong supporter of the trenches industry, the movement. And so, when you start looking at how their subscription has increased from 1992, about 20,000 to today over 45,000, and the conferences that they conduct, been a major factor and a major milestone in the advancement of our industry. Let's take a quick look at some of the things that's happened as far as the organizations. So we saw that in 1985, that's when we had the first No Dig conference in London, and that was a major successful event. I was not able to go to it, but I was able to get the proceedings, and the proceedings of that conference was really what inspired my career to focus on trenches technology, no dig solutions. But out of that 1985 conference, we saw enthusiasm start to build, momentum start to be generated, and just the next year, the formation of ISTT, the International Society, was established. Many things started happening after that. Many national chapters started being established. I was involved with the establishment of the Trenches Technology Center at Louisiana Tech. Went to Louisiana Tech in 1988, established the center along with the head of civil in 1989. And so that was one of the first things that really took place in North America. And I was part of 5 that's established the NASTT in 1991. 1992, the magazine was established, and then on that timeline, we started seeing NASTT sponsor the development of regional chapters and also student chapters. And one of the things that felt like was very important is that all of our problems, our challenges are local. So it's very important to have resources, not just at the national level, but also regionally to continue to support the industry. So we saw the Midwest chapter established in 1997, the Southeast chapter in 2000, and now there's quite a few chapters. So that's been a major development, about eight chapters, maybe more now. Also, we saw other research centers being established. The one at the University of Texas in Arlington was originally started at Michigan State, relocated to UTA in 2006. So now, so that was a major milestone in the industry. And also around that time, probably a little bit earlier, we saw that the research center in Waterloo, University of Waterloo, be established, called CATT, C-A-T-T, Center for Advancement of Trenches Technology, another research center. And the Mid-Atlantic chapter was established in 2004, and then in 2003, I was involved with the establishment of the Baird Asset Management Institute. And some people say, well, what does that really have to do with trenches technology? Well, it has a lot to do, because what we've got to be concerned about is making sure that the utilities are being managed properly from the standpoint of making sure that our assets are being the life of the assets being extended. So that gets into trenches solutions, the rehabilitation and so forth, condition assessment, being able to locate the asset. So all of that ties together. I've often said you can have the best pipeline condition assessment technology in the world and the best technical solutions in the world, but if you don't have that tied into some type of comprehensive asset management program, then you still may not be making the best decision for what needs to be done for that particular problem. So Security in place is certainly not new. It's one of the real exciting things that took place in our industry, because it was just a major breakthrough in technology. And I always want to give Eric Wood credit for the vision that he had and the ingeniousness that he had in order to create this solution. And it grew rapidly. Amazing to see how this company has been started and also managed and has grown worldwide. So it came into the United States in the late 70s, went public in around the 1980. They had a lot of major utilities that worked with them, WSSC, St. Louis, and I had major visionary people like Jerry Kalishman that really saw the potential for how to grow the companies and so forth. And now Aegeon is a parent company. They own a number of companies, and they're probably in the neighborhood of about a $1.3 billion operation now. And but what have we seen recently? We've seen that technology emerge from just using heat and steam, hot water and steam in order to do the curing, to now we see major advancements taking place in the light curing. The United States has been probably behind the curve a little bit on adopting this technology, but the acceptance and the organization is growing rapidly. So just less than 2 years ago, working with the Trenches Technology Center and working with industry, we were able to establish the International Light Curing Technology Association. The whole point here is to bring together the industry representatives in every aspect so that they can work together. And the whole point is to try to improve the design, the installation, the operation through the creation of partnerships among the utilities, the owners, the researchers, designers, contractors, and the industry itself. The whole idea is to make sure that we have a uniform program that can provide successful projects. And in doing that, we need to bring together the industry. And a lot of these industry players are competitors, but we want to make sure that they realize that if they don't work together, that the industry may never really achieve its potential. So there's a lot of benefits for working together. So this is how that organization looks today. So it's the International Light Curing Technology Association. We have an executive committee. I've been fortunate to serve on that. We have under that, in the organization, 4 major thrust areas or committees. One that deals with specs and the different type and testing programs and standard development and training and certification. And all of this has been achieved in less than 2 years, but there's a lot of activity that's going on and a very committed and dedicated group of people, professionals that's steering this. I want to move now to another area called subsurface utility engineering. And this is another area that we've seen develop. It involves a location of utilities and depiction of utilities. Mapping basically is what we're talking about. And we've seen that evolve from, say, witchcraft and guessing to using witching rods to utilizing different types of locating equipment to utilizing echo systems and ground penetrating radar. And most recently, we've seen major efforts being put into utilizing multi-sensory systems of various types. So it's just another example of how segments of our industry has grown. The one thing that we realize is that our industry must be focused on successful projects. And a successful project requires us to take a utility engineering approach. In other words, we've got to make sure that we understand the risk and how to identify the risk and manage the risk. And a lot of the risk has to do with trying to know what's underground, whether it's utilities or whether it's the geotechnical, geology. We must be able to have make sure that that's part of being able to design the projects properly and construct the project safely and successfully. So we've seen these techniques, the geophysical technologies become a very big part of our industry. We've seen how the ASCE has developed the standards with the committee on the standard guidelines for the collection and depiction of existing data, working with the Institute, ASCE's Institute, the Utility Engineering and Surveying Institute, PTC, and now BAMI is a partner. Purdue is a partner in this, and BAMI is a partner in this. We've got the organizations working together to really provide to the industry good training. This is a 5-day school that's been taught 7 times. We will have the 8th one in February at Louisiana Tech University at the Country Technology Center. And what we're really doing here, if you can imagine, really spending a week just learning how to understand the risk that's associated with these underground utilities. You know, we have an organization in the United States called the Common Ground Alliance. And we're informed that about 70% of the construction projects are delayed and have cost overrun because of issues related to utilities. We also know that we have over 500,000 incidents that happens with hits, and some of them are major events, but there's over 500,000 hits per year on the utilities. So this is a big deal, and it takes all of us working together. So in this particular area, we work with Hong Kong Polytechnic University. They have a strong program in utilizing geophysics to locate underground utilities. So it's a global issue and challenge. So this standard is ASC 3802, and if you are not familiar with it, I'd like for you to take time to learn about it. And it's not new. It's been published since 2002, and it's being updated this year, 2021. But it really gets into establishing the standard of practice on how to locate underground utilities, how to deal with the risk that's associated with underground utilities. And so, again, real leaders in this industry are the University of Birmingham in the UK, and also Hong Kong Polytechnic University. So these are major developments in our industry. This is a few pictures of some work that that's taking place in Hong Kong. It's developing certification programs for location of underground utilities. This is actually in a lab at the Hong Kong Polytechnic University. And these are some of the external evaluators as part of that program. A couple from the UK and myself, and some of the developers in Hong Kong. So this is a great program. Another part of our industry that's important in trying to make sure we have successful projects, of course, is the rapidly expanding area of pipeline condition assessment. And one of the real leaders in this area was an individual by the name of Norm Cerna. He got started in working with St. Louis in 1956 and was president of NASCO, the National Association of Sewer Service Companies, in 1991 and 1992. And while he was president of NASCO, he was also one of 5 of us that got together and saw that there was a real need to establish some leadership with Country Technology. So he was one of 5 that would work together in establishing NASTT. But we saw individuals like Norm become real leaders in the industry. We had companies like Q's that really jumped in and started advancing the equipment, and then Redstone Robotics. So we've had some real innovative, creative companies that have jumped in and really helped advance our industry. And one of the technologies that I had a chance to work with, this is an area that I realized back in the mid-90s that there was a real need to look at some different ways of collecting data and mapping. So I was involved in working with a couple of Japanese companies, in developing what became the source scanner and evaluation technology, which really was the first technology to take the pipe and scan the inside of it and lay it out flat. We also had built into the system a gyroscope and inclinometer for position determination. And the 13 cities you see mentioned over here were all part of beginning in about 1997, 8, and 1999, were all part of a 13-city North American group that came together to evaluate this technology. We did 10,000 feet in each one of these towns, and then they came together to help us to know how to advance the technology to the next phase to become a commercial system. And so that was all done under ASCE. At that time, they had a Civil Engineering Research Foundation, and so this program was done through that. Also, we see that technology continue to advance. This is a technology out of China that utilizes a 3D imaging technology. So what you see here is the results of a high definition high definition CCTV system that's gone through the pipe, collected the data, and now we can come back through and use the 3D imaging to stop and measure and pan and tilt. We didn't have to pan and tilt when we collected the data. We just collected data, digital data, but now we can come in and pan and tilt, measure things accurately, and be able to code the defects and determine the severity. This particular work here was validation work that we were doing at the Trenches Technology Center in Louisiana Tech. And our job there was to evaluate the technology and make sure that it can do what it claimed to do. And basically, what we really were doing is determining how accurate these measurements are. And so we were very pleased with the results. The other thing that we see taking place, and this is another work of validation work that we were doing at the Trenches Technology Center, and this is using specialized drones to go inside pipe and do condition assessment. And so we were able to do this work that was above ground just to see how it maneuvers within small diameter pipe, 24-inch pipe. In this particular case, it will actually fit into an 18-inch pipe, but it was really tight because the outside diameter is 16 inches. But once we got into the 24-inch pipe, we were able to maneuver and get really good condition assessment data. The other thing that we very excited to see develop in the U.S. was the microtunneling, even though it was a technology that originally developed in Japan, but it was migrated to the United States in 1985, and some major things started happening. Once that technology was introduced, it's actually a large diameter pipe, but in 1987, we started seeing the need for that capability, the microtunneling capability on smaller size pipe to put in typical wastewater systems. So we saw that technology really start to expand. We had in 1990, we had 3 companies that were here, Aseki and Sotal, here in Connect, that were really helping to advance the microtunneling industry. Some major players, Alex Mickey, I had an opportunity to work with him in the late 80s, early 90s. He was the representative for Aseki out of Japan. But Mike Garber has really been a major leader in this industry. He was the one that brought the smaller diameter microtunneling technology. to America and did the project in River Oaks that ended up being 3.8 miles of small diameter sanitary sewer system. And then Paul Nicholas was one of the individuals that really helped advance the industry through his knowledge and his experience and what he was able to do to increase the awareness of the technology. All of that led to the development of a ASCE standard on design and construction guidelines for microtunneling. This is actually the second edition that came out in 2015, and it's about, I think the first edition probably came out in the late 90s, but this one is very much advanced and very thorough, comprehensive document that can be used for planning, designing, and constructing microtunneling systems. So when you really look at the amazing technology capability, I just like to describe this particular project. And we had a PhD student from China that came over and spent a year with us at Louisiana Tech at the TTC. During that time, I was able to go visit this project when he was on this project. Before he came to TTC, he spent a year on this particular project. But it really exemplifies the technology, the capability of the technology. When you really look at this particular project, you see the amazing capability. There's 36 pipes that were microtunneled to build this structure. These pipes were almost 64 inches in diameter, each one of those pipe, and they had a distance between them of about 14 inches. And you can see the shape. The shape is an oval shape, and the inside diameter, inside dimensions, very large. And the whole point here, this is a transportation tunnel, but we use it to exemplify just the capability of how we can use microtunneling in order to build a support structure, basically a temporary support structure, so that we can build a tunnel inside of it. Those pipes were actually used for ground freezing. So the whole perimeter of this structure was frozen with these steel pipe. The amazing thing about this, the pipe, building the pipe, all of them were on a curve, so it's curved microtunneling, and they were being built from each direction. In other words, you had two machines working all the time, going in each direction. So it was a very successful project, and as far as I know, there was no real major issues that took place. But one of the things they did, if you look at that pipe up in the right corner, upper right corner, 0, they did it first, just to prove that that they could do this, if they could maintain the line and grade and on a curve. And so they did a test run first, then they jumped in and did all 36. So just a real credit to the technology. One of the things that I see in the future is utilizing microtunneling with PVC pipe in more places than Japan. This has been done for years, almost 30 years in Japan, but we haven't seen it. We saw microtunneling expand from Japan, but not with PVC pipe. We did one project using this type of a joint, PVC pipe with this type of a joint on our campus as a demonstration project, research project, and it went extremely well. And but we haven't seen it being used commercially. And we did 200 feet in 4 different types of soil in a test pit, a test section on our campus. But now I'm hearing more and more about the interest of using PVC pipe, particularly for the smaller diameters in some of the municipalities. So I appreciate this opportunity to have been with you to talk about some of the milestones. Sometimes we just need to stop and look back and just see some of the amazing things that have that have made up our industry and that have got us to where we are today. And I would like to end by just saying that I think the most advancements and expansions and so forth are still yet to come in our industry. So I say that because I just see so much research and development taking place at so many different places in our universities, a number of universities around the world, but also our companies. And I'm seeing that owners of the infrastructure are realizing that they too need to be part of advancing our industry. They are the owners, and often they are characterized by being very conservative, but they many of them are realizing that they can benefit from advanced technology. We see it in every aspect of our lives, and our underground infrastructure is no exception to that. So with that, I'll say that I wish I could be in India for this conference, but it didn't work out that way. But I appreciate the opportunity of being able to share some of my thoughts with you. Thank you very much.